Good afternoon, Vamshita. Good afternoon. Welcome, guys. Welcome. How's everyone? Just give me a minute. Hello, guys. Hello, hello. Manu, welcome. Ronak, welcome. Spurti, welcome. Hello, Nitin. Good afternoon. Sanju, welcome. Kim, good afternoon. Viviana, good afternoon. Harika, good afternoon. Sneha, welcome. Hello, Nishant, welcome. Vishwajit, hello. Hello, Venu. Hello, Rashmi. Hello, Pramod. How are you? Chandana, Nikhil, welcome. Yukta, welcome. Nitish, good afternoon. How you guys doing? Good afternoon. Good afternoon. Pritesh, welcome. Shubham, welcome. Shubham, welcome. Sorry about that message thing. Yeah, fine. Okay, guys. So we shall start this CNS thing. Hello, Sunil. Welcome. Shweta, welcome. Yelappa, welcome. Vatsa, good afternoon. Swati, good afternoon. Okay, good afternoon, one and all. Hello, Divya. Welcome. Srinivas. Doing well, sir. How is quarantine treating treating you all? It's been fine, I guess. We are not forced to stay at home. This is for us, right? For our protection, for our safety. So it's fine. It's fine with me. Hello, Sparsha. Spurti, Shruti, welcome. Hello, Ashwarya. Okay, guys. So now that I have welcomed you all, we'll talk about our business authentication. Hello, Trojan, YT, Asha, welcome. Yeah. So, guys, the thing is authentication, right? And before I talk about this, Saida, welcome. Fatima, welcome. Yeah, before I talk about authentication, I have seen one small issue. I don't know, people are doing it for fun or something. Hello, Adil, welcome. The thing is, exactly the same thing what we're talking here about authentication. Some people are, impersonating as someone else. Like we can see two names of the same account, and they will be telling something to faculties. That has come to my notice. Yeah, and don't do that. There's no need to do it. Just, just log in here with your own name. So anyway, authentication, we were talking about what is that, one way authentication, and we stopped till here. And how it happened on the basis of challenge and response protocol. What usually happens, there is a party who is nothing but a prover. I am proving myself to be the genuine. I want to authenticate myself. Server on the other hand is the verifier. Good afternoon, Shivani. Ratna, welcome. Rajeshwari, welcome. Menka, welcome. How are you? Aditya, welcome. Present, sir. Good. Anyway, so that party server is your verifier, right? How it works? A is the first message. We usually have seen three messages, right? For all the ends. Purnima, welcome. Good afternoon. So A is trying to send its identity. For that, good afternoon, Jashish. For that, server will send a challenge to the party A. So for that, it has to send a response to authenticate himself. That's the scenario we have seen. But there, in one way, only I am or party A is trying to prove himself. But there might be some cases where both communicating parties, they need to authenticate themselves to each other. For example, I told about internet banking. It is very important that customer interacts with his own bank, right? And similarly, it's very important for the bank to verify the identity of the customer. That is called as your mutual authentication. All right, guys, let me take a snapshot with you all. Uh, Hold on a second. Yeah. So there are three modes of doing it, mutual authentication. First is using shared secret key, using asymmetric key. Asymmetric is nothing but your public, and last one is your combination of both. So the first one, as you can see here, we have three diagrams we are seeing here in shared secret based authentication. Pramod, good afternoon. Sanjay, good afternoon. Welcome. And guys, one more thing, as everyone is here, so I will just say this right now. As soon as the session ends, please fill out that form before 3. After that, I will be closing it out and send the attendance. Okay, that's all about it. So what happens here in shared secret, there is one concept which we have accepted, but it has flaws. So let us talk about that itself. So basically, if you see the first figure, the flood protocol, there are 3 messages, right? A and B. A, let's say yeah. So A is communicating its identity, right? And its challenges in the form of a nonce. We know what is nonce, number used only once. Nonce is the number used only once, and it is not represented by n, it is represented by r. It's a random number, that's why random number used only once, so r. Here it is a nonce of A, so it is represented as R of A, identity of A, and a challenge in the form of random number R of A. See the message 2. Message 2 is a is a response to the challenge by, you can see that E of K. When you see E of K, K is the key, right? And it's not P of PU, PR, it's K, means it's a common key, common secret key. The name itself of this authentication is shared secret, means same key is used for encryption and decryption. So K is the key, common key. So basically what happens in second message, B responds to the challenge by encrypting RA with what? With the common secret key K that is shared by both A and B. That's about it. Now, good afternoon Navya. Good afternoon Chandana. Harshita, welcome. Right guys. So message 3, what happens? Good afternoon Jashish once again. Yeah, so what happens in message 3? A again send a response to B challenge in the third message to complete the protocol for mutual authentication. But there are some serious flaws on it. What are the flaws? See the second figure, the parallel session attack, the second figure. What happens in the scenario here is, let's say C is the attacker. C is the attacker. So this will be uploaded on YouTube after this session, and yes, the complete session will be right there in the YouTube. You can watch this video again at any point of time. Don't worry about it. It will be there. सर जो पहले किया था वो फेक आईडी है कोई? Fine, please don't do that, all those things. Okay, I don't want to do any all those things, troubles and all. So what happens, attacker, instead of A sending the communication to B, C is the party, attacker, who is sending it to B, right? Impersonating as A. So basically you can see the concept of proxy. What we are seeing here is proxy, right? Someone else is using someone else's ID, it might be, and it's communicating to the server, right? And server will I will communicate with, thinking it's a genuine party, I'll communicate it to him, and once he got the agreement from the server that yeah, they have agreed to me, so this party again, that attacker again will communicate to the original party A. So it is like in the middle. He's a man in the middle. He's communicating with both the parties as a proxy. Double attendance. Fine. So that's the attack. It's vulnerable to this parallel session attack. Okay. So what is the corrected protocol for it? I will keep it very short. See the message. The first message is same. A and random number A and the B, that is also is the same. E K of RA, but here something else. Instead of just R of B, we have EK, encryption of RB using secret key K. Whereas the third message, here also some one extra thing is there, that is decryption, right? Decryption key of E of K RB. So basically, what is the scenario here? If we can encrypt both RA, if we can encrypt both RA and RB, we can make a correct protocol for mutual authentication using shared secret. That's the scenario actually. So that's about your shared secret. Next thing is your asymmetric. It's just like we talked about secret key cryptography. Now we're talking about public key cryptography. Asymmetric is another name of public key cryptography, right? So here you can tell it is like two keys will be used for encryption and decryption, and it's the same thing. Now if you see the diagram here, flawed protocol, what is decay? Okay, let's go back to the previous one. Decay is nothing but your decryption. I told when there is something like EK, it means encryption of something. Let's say RA, encryption of RA. Just hold on. Okay, when I say something like EK, it means encryption of RA here, right? What will be decay? Obviously, it will be decryption of that, right? It's very simple. Okay, basically, it's a challenge given by the server to if you want to authenticate yourself, you have to accept my challenge and decrypt the message I have sent. Then only I can identify you are the genuine person. That's the challenge. Okay, that's what is your DK. Okay, Atia, welcome. Good afternoon. Okay, good. That's very good that you have asked that question. Anyway, so we talk about this one, mutual authentication using next one, asymmetric key based authentication. So you see the figure, first figure, flawed protocol. Uh, what happens in message 1? Identity of A, when there's something like double quotes and A, so identity of A. What is the next thing? Challenge sent by A. Challenge sent by A is represented as R of A, random nonce, number used only once. Okay, identity of A is A, challenge is R of A, and something else, but that is called as A's certificate. That means a digital certificate which contains signature of A. Okay, message 2, you see the message 2, it's a string obtained by concatenating RA RB, that is signed by B, and B's certificate. You see the how it is reading, it is RA comma RB whole of B. It's a string obtained by concatenating RA RB, which is signed by B, and also comma B certificate. Okay, you just have to remember and elaborate that, but don't miss on students what mistake they will do. They will write RB as EK H of K, because they will not understand the concept. They will make this kind of small mistakes that will result in, like teacher will think they have not understood the concept, they have made a mistake. So make sure you read those things very carefully. What is the meaning of it? The last message 3 you have, it's again RB is the nothing but a challenge signed by A. When I write something like RB, hold on, when I write something like B of A. It means what? It means RB is a challenge signed by A and it is encrypted using A's private key. Okay. See, that is a flawed protocol. This is a flawed protocol here, right here. So, and again there is a attack on that. You see the middle diagram. Again, this time it is not C at the first. It's exact. It's a previous example was not for man in the middle attack, but this one is actually an example of man in the middle attack. A, C, and B. That was like using a proxy. The previous one. Okay. So it's the same kind of attack how we have discussed earlier, man in the middle attack, that is happening here. So see, you see the corrected version of it, how it can be corrected. See the third diagram, corrected protocol. So one solution to the above problem is for these entities A and B to include the identity of the recipient in all the messages they are signing. Include the identity of the recipient in all the messages they are signing. So what happens? You see, the message one is same. A is the identity, RA is the challenge by A. So message 2, see the message 2, it's a string obtained by concatenating nonce RA and RB that is signed by B. Okay, that's how it is. So what is happening, including the identity of the recipient in message that is signed. In the message 3, RB is the challenge provided by B and signed by A in response. I'll repeat, RB is the in message 3 is a challenge provided by B. You see the third figure. It's a challenge provided by B and signed by A in the response. Okay, so that is how you will correct this mutual authentication using asymmetric key based authentication. The question can come like, explain the mutual authentication using asymmetric key based authentication or shared secret as a separate question for 6 marks each. Fine. So this is last one. Here we have mutual authentication using mutual authentication and key agreement. So both are things are used, secret and public together, right? So what happened in the previous sections, authentication was performed using operations involving a long-term or a private key. Long-term, shared secret, or I will call it as private key, is the same thing. But the problem with private keys are to implement those operations, they are very expensive, and the communication can be integrity protected. Means to say, instead we should not use that. We should encrypt using short-term keys, or also called as your session keys. I'll just repeat. Authentication was performed using operations involving long-term, shared secret, or private key. All those things are same. So instead we should use short-term keys like session keys that we have discussed. Now here what they're using, session keys, and they're donating it as SA and SB. You see the message 2 and message 3 in the both figures. You can see one more extra entity is added, that is your SB is session key for B, A is session key for A. So it's the same thing. Again, A is sending the identity and the challenge, B is again encrypting using the same key here. You can see that E of K, R of A, then again E of K, R of B, S of B. That's a session key also included. But in the first one, you were seeing key is used as only K, only one key is used, K. But in the public key cryptography, you will see concept is almost similar, but instead of using that K as the key, they are using public key and private key, basically combination of two keys. So that's about this question. Next thing is, hello Sakib, welcome. Hello Saida, welcome guys. So next thing is timestamp. What is actually a timestamp? We have used a random number n, r, nonce we call it, and it has some purpose. Now, is it enough? First of all, if it is not enough, what else we can use? That is your timestamp stamps. So basically, we talk about nonce first. The use of nonce, it was introduced to prevent replay attacks. We know if the attacker can, if he doesn't get the actual password or actual information, he can use that information to play it again and again unless he recovers the password or actual information. Now each party generates a nonce which is used as a fresh challenge to the other party, and this recipient is often expected to sign or encrypt the challenge using a secret node to only the recipient. Now, but the thing is, the key idea here is the freshness of nonce, whether it is actually recently created or not, whether it is being reused or from the previous session, because if it is used from the previous session, that is your replay attack, right? So alternative to that nonce is called as your timestamps. So what timestamp does, it stamp on a message with a current time, like this is a time it is being created, and it indicates your freshness of the message. So this is the figure here, mutual authentication using timestamp. We have what we have, two messages, A to B. What we can read, how we can read that inside. Message 1 is sending. First of all, in message A inserts a timestamp TA, T of A, T and small a. We call it as timestamp of A, and then after inserting the timestamp, signs on it. Okay. B on the receiving message checks whether the timestamp is recent, and then it verifies if it is recent, then only it verifies the timestamp signature. Okay, that's how it is. So what happens then, he increments the received timestamp, insert into his own response to message to A, and then signs the message. Now if the clocks are being maintained, let's say we have timestamp, right? So there's a concept of synchronization between A and B. So if the clocks are maintained between A and B and they are synchronized, so the timestamp in the message 1, which is being signed by A, convinces the B party that message is fresh or freshly created by A. Now it is nothing but timestamp is already also serving as A's challenge to B. Now by signing the timestamp, B hopes to satisfy that it is indeed responding to the messages. Okay, so that's the concept of timestamp. This can also be asked for 6 marks. Explain the concept of timestamps in mutual authentication, or how does it replace nonce? How is it like an alternative to using nonce? Okay, so the last concept of today's class is your dictionary attacks. It's very simple. Dictionary attacks is like in terms of password. Some passwords have large characters, some passwords have small characters. Some people will write password as their date of birth, combination of their phone number, some pin, or some their ex-girlfriend's names and all. Some people will do anyway. So and so that it will the concept here is to easily memorize those passwords. We should not forget, right? So for password should not be weak. We cannot write password like A123 ABCD, or some default password is like your name in reverse, something like that. Or see this part here, we have anything less than 8 characters is too short. It's a basic thing what we already know. You guys are already aware of that. See that NAHKHKURHASS, that's a Shah Rukh Khan name written in reverse. Okay, people will do that. So for these kind of weakly written password are prone to being attacked. So what kind of attacks? First of all, online attack and offline attack. So in online attack, what happens? Intruder attempts to log in to the victim's account by using victim's login name and guessed password. Okay, so there is usually system impose limit on the number of failed login attempts. We know if we log into the any banking thing and we fail to enter the password 3 times, it will block us for the day, something like that. So online attack has a limited chance of success for in terms of thinking in the hacker's manner. Now offline attack like is like intruder gets the password by tracing the password file or eavesdropping on the line of communication, and or you can also do some kind of a replay attack, play the communication again and again to deduce the actual password. So what is the concept of defeating these dictionary attacks? Is one approach is to frustrate a dictionary attack so that the increase so that to increase the cost of performing such kind of attack. Cost is in the terms of time to successfully complete the attack. So that way we can frustrate the attacker to if the attacker if we can frustrate the attacker to perform a successful attack, we are actually doing something good in terms of preventing our attacks, right? Fine. So that's all about it. That's all for this class, guys, and this covers your module 3 chapter 2 also. First chapter was key agreement. What we are saying is now is authentication 1. This is part 2 of authentication 1. I have done part 1 in the yesterday's class. Tomorrow I will not be taking any CNS class, and tomorrow there is no CNS class, yeah, and day after tomorrow I will take CNS class. So yeah, that's all, guys, and if you have anything, please let me know. I will send a Google form right after this. Please fill out that form. That is very important. Before 3, please fill out that form. And yeah, that's all. I will and one more thing, guys, for CS2 I will take OS tomorrow. For CS2 specifically I will take OS tomorrow, maybe at this time itself, but that will be in Google Meet. Okay, I will let you know all those things. And Shubham, yeah, thank you for your USN. And guys, thank you everyone. Please fill out that form, Google form, and thank you for joining. I'll see you day after tomorrow in CNS class. All right, guys, take care. All right, guys, take care. Bye. Thank you for joining.